Right. So definitely keep that window open. If you're basically if you're interested more in a liquid fuel, I think that our team would still be very happy to work with you on that. So don't feel like the report from 3 years ago is sort of like closing the book on it. Your
Got it.
next question is, your next question is, we understand SAF is critical for aviation, but the L2201 research paper, this is by Rachel and team, explicitly states that this strain accumulated more cellulose and lignin than CV2. The paper further notes that while high cellulose is good for ethanol, high lignin can hinder enzymatic saccharification, but is advantageous for biochar production due to lignin's high carbon content and thermal stability. So your question is, given L2201 specific high lignin profile, would you agree that trying to convert it into SAF via hydrolysis fermentation would be chemically inefficient compared to pyrolysing it for hydrogen or biochar? Maybe, I don't know if Rachel or someone on the team there can help us answer this question. This is about, is L2201 appropriate for sustainable aviation fuel? Rachel, 你有意见吗?
Okay. Maybe I can answer from plant aspect.
Okay.
Yeah, because as we know that lignin, whenever napier grass grow older, the lignin content will increase. And in this study, actually, we used the quite old stage. The lignin content is quite high. And depend on the, because we want the higher biomass. So actually, if depend on the purpose, maybe you can harvest earlier, maybe 10 months or 16 months to reduce the lignin content and cellulose content. Yeah, for biochar, I think high lignin is good, but the other aspect, you need to focus on maybe younger stage.
Okay, so Garang and Vina, for your awareness, so Rachel is breeding this Napier grass and analyzing all of its characteristics, like for drought resistance and temperature resistance, and doing all sorts of permutations. And then your next question was, are we correct in assuming this crop was bred specifically for thermal conversion, not fermentation? Is that correct, Rachel, or not specifically thermal versus fermentation?
This L2201 actually is not bred by us. It is from our Taiwan Livestock Research Institute. Their purpose actually is for the livestock. So, but they have very high stem. Then we think it is good for biochar. Then we follow up the record of this LL201.
Okay. So it sounds like, go ahead, Rachel.
Yeah, it is high biomass and more tolerant to low temperature.
Right.
So we think this is good for our subtropical Taiwan environment because a lot of winter low temperature inhibit the growth. So if we want to increase the biomass, we would like to have a cold tolerant variety.
Okay.
But as I know that the different growth stage, the cellulose and lignin will accumulate gradually. Okay? Yeah.
Understood. So would it be possible to sort of share some more research on the L2201 and maybe even like, some photos, like what it actually looks like in the field when you cut it at different ages? Because what I'm understanding is that when it's younger, then the lignin content is lower, but then it changes over time.
Yes.
But like as it gets taller and it accumulates more biomass, then my hypothesis would be like we let it grow and then use it for biochar, and that might be like more chemically efficient. So any sort of more research or documentation would be very helpful. The second question is, given that L2201 has been bred for the cattle, uh, like that is like the competing use, right? And we would have to prove that using it for biochar will help the farmers more than using it for cattle. Because the paper also mentions like there's like some specific area in Taiwan, like 50,000 hectares of fallow land, like that's in the policy recommendation documentation. So we would have to convince the farmers that instead of letting your cattle eat the grass, let it grow and then we'll use it for biochar, right? So if there's any unit economics or any research on the cattle industry and how that works, like how much money farmers make right now from the cattle, etc., that would be helpful.
This question maybe I cannot answer, but as I know, we try to push on this L2201. They have a good trait of high biomass, especially during winter, and high lignin content for biochar. And also we want to avoid the cultivar, the popular cultivar that for the cattle, food crop of animal, to separate purpose, not compete with the animal food.
Okay,
the
got
it. Too is animal food. Yeah.
Understood.
Okay, great. And I think we can probably get you some photos of what the Napier grass looks like. It grows very tall, 3 meters tall in Tainan, and grows very, very quickly. So I'll take an action to relay that to you guys.
Are there certain soil conditions in which the Napier grass grows? Or is it only that the grass grows in like farm conditions? For example, I know that Taiwan has many mountainous regions. Will this grass also be able to grow in those areas?
Rachel, do we know, can this grass grow in mountainous areas?
In where?
Mount Taishan the Dichu.
Yes. We also found a lot of, we collect some cold tolerant variety in the mountain. Whenever I think that is possible to plant it in mountain area whenever the irrigation is enough. But the problem maybe you need to think of is that the mechanical harvest problem. Mechanical need the more flat. The field, if it is a mountain, maybe not easy for machine do the harvest. Maybe the land should be more flat, And I think it's, the cold tolerant, some is have the trait of cold tolerant. We even have collect some from the 180 meters highland and grow very well. So we'll test it whether it's good. Really
Okay.
cold tolerant,
Okay, great. So very good cold tolerance, guys, which actually would lend itself to high altitude farming if that's a model you're interested to look at. Maybe there is a model around growing it in small patches locally, and if there's carbon credits around, micro plots, you know, that could maybe be a way to do it. Cool. Let me move on to the next part. Let's see. Okay, so this is specifically around biochar and the ash and silica content. So the L2201 species has a higher silica ash content than wood. What is the specific ash content percentage of the biochar produced? And if it's high, greater than 5 to 10%, does it disqualify from being used as carbon black for tires without expensive acid washing? So I don't know if this is a Rachel question or anyone else on the
Maybe
call from our side. Go ahead.
Professor Lin from National Chong Kung University can answer this one.
Okay.
Oh, yes.
Lin Lao Sư.
Okay. Can I show my slide? Yes. It's possible?
Sure. I'll stop sharing and then let you start sharing.
Okay. 哎，怎么共用？Sorry.
Let me see if I can allow you to share.
Yes. Yeah. Everybody see the slide?
It's coming up now. Yep, we see it.
Yeah. It's a procedure for produce the Napier grass biochar with sun dried and granulation and carbonization. Yeah, it's a granulation machine under the size of the Napier grass. It's around the diameter is 0.8 centimeter and the length about 8 centimeter. Yeah, my work is focused on developing a simple and cheap system to produce biochar. So we established the carbonization system in Guantian. And the concept to produce this carbonization system is quite easy. I use the TLUD system. That's tap lit updraft. In this system, we don't produce any hydrogen gas. We just use a fire to pyrolysis the biochar. First step, we light the fire, and the cellulose and the hemicellulose would be burned off to keep the high temperature, and then gradually convert to the lignin to carbon, and we get the biochar. This process is quite simple and fast. Well, in Guantian, this picture shows the system we established in Guantian. Yeah, every day we can deal with about 90 kilograms, 900 kilograms by the raw material, and to produce about 100 kilogram biochar. Yeah, that's the Napier grass granulated. After carbonization, we get biochar, and the surface area of the biochar is quite high. It's around 300 meter square per gram, and we always keep in high temperatures condition for carbonization to prevent the formation of dioxin. Yeah. Actually, in the resulted biochar, the ash contains about 41%. And the ash, the major component is silica, SiO2. Yeah. And for biochars used in farm, we must have a check on the dioxin content. From our system, the dioxin content is quite low. It's lower than the IBI standard, less than 0.02 nanogram per gram. In our system, we produce biochar only 0.001 nanogram per grain. That's fit to the criteria. And also we must examine the pH. pH contents should be less than 6 microgram per kilogram. In our biochar, just only 0.8. So it's fit the criteria to use in farm. But our government has a concern on the quality of the biochar. So in Taiwan, our government is not allowed biochar put into the farm. So yeah, I must say that. Yeah. Okay. For applications of biochars, I have an idea about. We use as a VOC absorbent. I cooperate with the Industry Technology and Research Institute in Taiwan. We measure the absorption capability. 1 grams biochar can absorb 0.005 VOC. Yeah. So it can be used as absorbent to absorb VOC in car or any closed system. Yeah, I think it's one of the application. The other applications I suggest is about clothing. The clothing, even though the carbon's material have a physical heat absorption and the radiation capability, so it can release far infrared radiation. So the material always frequently utilized in thermal clothing. So I cooperate with a company to produce these clothings. Yeah, and for about the tire, actually in tire we also have the carbon breaker and silica. So in the biochar from the Napier grass also contain the carbon part and also silica component. So it should be considered as a raw material to replace the feeder in the tire. That's my suggest. Okay, I think.
Thank you. Thank you, Dr. Lin. So I didn't realize this. So far, Taiwan does not allow biochar as fertilizer. Is that correct?
Yes.
Okay. So that seems important. Do you think that in the future it may be allowed, or that seems unlikely?
They're concerned about the quality of the biochar.
Oh, okay.
Yeah.
Okay.
Actually, I produced the biochar to I think to fit the criteria of the EBC and IBI standard. But other system I cannot make sure. Actually, okay. So our government is concerned about that.
Right. Okay. Go ahead.
This is oh, sorry, I see someone has the hand up.
Yeah. For the biochar, I think because Taiwan, actually, we have a lot of acidic soil. And actually, biochar is a very pH high, around 9 to 10. Instead of putting the fertile farmland, maybe it's good to improve the acidic soil, like the red soil. I think it's maybe, I'm not sure whether government can accept this suggestion or not. Yeah.
Okay.
Okay.
Thank you, Rachel. Was it Garang? You had a question?
Yeah, no, this is super critical information if the biochar isn't allowed to be applied. One follow-up, you mentioned the tires and clothing as potential applications of biochar. And I know there's like research been done generally that you can use biochar, but I'm curious whether there's any research on the Napier grass biochar specifically, like whether it is suitable for, and there's also use case in concrete, for example. So I'm curious if there's any research on like use cases of Napier biochar in industry. What is feasible? What is not feasible?
Okay. I think the biochar from Napier grass has high silica content. That should be suitable use in concrete. Silica. Others for biochar from wood, the silica content is quite low, just only carbon, so no silica component. So it's not suitable for mixed with the concrete. Yeah, concrete condensations increasing the including the calcite and silica condensation reaction. So if the component, the filler component has silica, should be better to add into the concrete. But we must know about the price. Biochar, the produced price is high, but when we put into the concrete price is too low. If we can find a special function or unique function, then we can have the market. Otherwise, just as a normal filler, I don't agree. It's a business. Yeah. It's my answer. Yeah. Thank you.
Got it. Dr. Lin, do you have a recommendation where Garang and Vinav would want to target for a commercial business plan? Would you want somebody to create a business plan around what would you recommend? What's a good angle for them?
I suppose put into the for the clothing, it's better.
Clothing.
Yeah, clothing, because a biochar has a lot of porosity. Porosity can absorb the VOC and also the art from our body, and also can absorb the humidity, and also can release the far infrared, so keep the warmer. So then it's better than other materials, even the graphite or graphene. Yeah. Graphene do not have a high surface area and porosity, but the biochar has a high surface area, and also porosity.
Right.
Okay. It's better. Yeah.
All right. And especially as climate change gets hotter, maybe we need clothes that are more breathable. Cool. Lin Lao Shi, are you? Oh, go ahead.
If we could have that
Good.
slide with all the properties, like that was super helpful actually, because then we can look based on the properties what is appropriate and what is not appropriate.
Right. Lin Lao Shi, are you okay to share your presentation?
Sure,
with
no
us?
problem. Yes, okay.
Okay, go ahead.
Okay.
I put my email in the chat, so you can just email it to me and I'll share it with everybody. What's it, Mark? All right, while he's doing that, let me go back to the list of questions. So you had a question, what is the fixed carbon percentage after pyrolysis? Is it high enough for So I think Dr. Lin's presentation answers a lot of these questions, also around porosity and surface area, and HC ratio. Are you guys okay if we just use Professor Lin's feedback on these?
Yeah.
types of-
Offline answer is perfect.
Thank you.
Okay,
Yeah.
great. Yeah.
I think the hydrogen to carbon ratio of the biochar is less than 0.4. It's our biochar is only 0.6, 0.36. Yeah.
Got it.
Okay,
is
then
super.
we can make carbon credits. So that's good.
I'm learning a ton about biochar today. All right, moving on to the next question. what biochar can be used chemically for contaminants. Are there heavy metals or high levels of potassium chloride in the biochar that might leach out? I guess this would have been relevant if, well, you're saying also for construction, right? But if we're not using it for agriculture, that question is maybe not as relevant. Do we still need an answer on this one, guys? What do you think?
No, I think it's okay.
Okay. And the conversion ratio, do we have specific lab data on, people are waving at me as I'm talking. Do you have specific lab data on the mass balance conversion of L2201? Specifically, what is the expected yield of hydrogen versus biochar? I think, Rachel, you may have done this kind of research on the amount of hydrogen content.
Dr. Lin help us to do the analysis. Maybe Professor Lin can answer this.
Oh, okay, sorry.
What question? Sorry.
The question is about hydrogen content. Do we have data on?
Yes. I will fix my slide and add the hydrogen to carbon ratios data in our revised slide. Okay.
Okay. Great, thank you. And then we have also questions around cost of cultivation. Do we have any research on the growing cost, specifically as relates to the ultimate energy usage, or not there yet?
Yuting, do you have, Dr. Shi, do you have the data?
I just have the conversion rate. May I show the slide?
Sure. Let me stop sharing and you can share.
Yes. Yeah. Okay. We just only talking about the conversion rate. The x-axis is the GPP, and then y-axis is the harvest biomass. And I use the time as the CO2, so you can convert it to carbon. So the ratio means the conversion rate means the ratio. So the ratio means maybe 60% of GPP will convert to biomass. Maybe it is you want the value. So this is our observed data. So maybe you can use it to use the GPP. If somebody told you the GPP or somebody told you the harvest biomass, you can convert it to carbon sink. Yes, maybe you can try to use this. And if you want to know how much harvest biomass will convert to biochar, maybe it is 0.5. It is the data is came from the Professor Lin. He uses some EA to analyze the carbon and the other element. Yes.
Okay,
yes.
Great.
Okay, yes.
Thank you, Professor Shi. And
yeah.
So this gets to the content, but we don't have cost estimate, right, for growing Langwei Cao yet, right? We don't have like a total cost of energy estimate so far.
No, we haven't.
Not yet.
Not yet.
Yeah, so we're still growing the thing and analyzing it. We don't have a cost yet, guys.
Yeah, we just only analyze the money we cost. We haven't analyzed to calculate the energy we cost. Not yet. Yes.
I mean, honestly, guys, that alone could be an interesting business plan, is just help us figure out the overall potential revenue, whether it's for clothing, whether it's for energy, or whatever viable use, but help us figure out the potential market for this stuff, because I don't think we've done that so far.
Yeah, that sounds great. And I know that Professor Lin like talked a lot about the porosity. Have you by any chance looked at all about, I know you mentioned that you could do the VOC sequestration, but have you looked at maybe like water filtration or catalysis?
For catalysis, yeah, it also can decompose the ozone of the Napier grass biochar. It's very special because it also contains the silica and the carbons. Silica component can catalyze the decomposition of the ozone. It is, ozone is a pollutant in closed system, even in car. So the ozone's concentration also higher than the standard. So if in car we can put it, some Napier's grass biochar can remove and reduce the ozone in car. Yeah, or maybe some in some closed system, even in indoors house. Yeah, it's okay. Yeah. It's another special property.
Do you know
Wow,
if
okay.
Oh, go ahead, sorry.
No, I was just saying, wow, okay.
Yeah. Do you know if it would also like take in the PM 2.5 or PM 10?
Yes. For our systems, we always try to have a completely burning of the evaporator, then reduce the PM 0.2 or PM 10. Actually, it still have some PM 2 or PM 10, but it's lower than the standard in our carbonization system during carbonization process. Yeah, it's okay.
Okay, great. Are you guys covered on that that row of questions? I'll go back to our list of questions. And Shi Lao Shi, if you're okay to send your presentation as well, I put my what's that amaka? You can
Okay.
email it to me if possible. 我的英文名字是 Mark Antonison.
Okay.
Okay.
I will show you.
All right, thank you. Next question is, your presentation mentions using hydrogen and solid oxide fuel cells and EHP purification. Does the pyrolysis gas from Napier grass require extensive and expensive purification to be used in fuel cells? Or should our business plan target a simpler application like co-firing in gas turbines for the grid? Is this a Lin Lao Shi question? Is there a pathway to use this for fuel cells, do you think, for creating hydrogen?
My work only focus on the biochar for a fuel cell or hydrogen.
I mean, I think we have other teams looking at breaking down this grass into component chemicals and then creating syngas and then creating hydrogen for fuel cells.
I suggest directly convert into hydrogen, and biochar is more suitable. Not
Right.
because there are too many steps. Are also cost, and the cost is too high, and then we cannot have any economic value.
Okay, let me ask some of our other folks on the team. David, 你看这个问题，他们在问，如果他们应该针对做 用那个狼尾草做氢能，然后用那个氢能在 solid oxide fuel cell 发电，你有什么意见吗？
I'm not sure. And
Okay.
I agree this
I think if your idea is
Okay.
workable, we will appreciate any idea that is workable. And maybe I'm not sure.
Okay.
Hmm.
All right. So Garang and Vinab, we're having a bit of discussion behind the scenes here. We're going to get you a clearer answer on this from people looking at this specific pathway,
Perfect.
whether that's viable or not. And then the last question here is, while L2201 is cold tolerant, the research notes that drought stress could retard growth. Do yield projections require irrigation in southern Taiwan's dry winter? And would this affect your revenue? This is very much a Rachel question. So this is about, Rachel Laoshi, this is about drought stress.
Mhm.
And would we have to add irrigation if it's dry winter?
Yes. If we have the irrigation, I think the biomass will increase quite significantly for napier grass. It's very important because they need a lot of water to grow. So, but I think it's worth to do the irrigation. The cost, I think, compared to the biomass, I think is efficient to more input of the water. But I know it will increase the cost.
Okay, so yeah, it could increase the cost, right? Okay. Great.
Are there any thoughts on the napier grass for soil stabilization, especially on, say, like Taiwan's a lot of slopes in the mountains, and so there could be like issues in soil erosion? Are there thoughts on like the root structure of the grass and whether it makes a significant difference for soil improvement purposes?
I think this is a good question. I try to answer a little bit. Maybe you need a more shorter variety because whenever you have very tall, dropping problem will be a big problem in this production. So you need, but I know that the root system is good. The napier grass, they can have very long root for stabilize the soil. I think it's good idea. But same problem if for machine harvesting on the mountain, is that possible? Is a big issue. If this is a large scale, I think you need to consider it.
Yeah. So it does have soil stabilization properties, right? It's not like negative for the soil in terms of root structure.
The root structure, I think it's good to keep from the erosion of the soil. Because they have a lot of fibrous root and long to keep
Okay, so guys, it sounds.
Yeah, the height is the problem. Maybe not too high.
Oh, okay.
Shorter one, yeah.
Okay, so it sounds like it is a soil stabilizer, but growing it on a mountainside limits how easy it is to harvest it. But it's not like other crops that are maybe damage or create more erosion. Cool. Any more questions along this angle, guys? Or I can move on to the next batch. All right, let me move on to your next question was around introductions to people working on commercialization of of carbon sequestration. So we had a look at this question. We think in a short term, like the next couple of weeks, it would be hard to line up these sorts of conversations directly with these companies or with the market. But we do have some experts on deck who are consultants in the carbon credit space that may be able to answer a lot of these questions for you. So we're going to try to find one or two people to stand in the next week or two to get you some market input in this space.
Perfect. And in the business model, can we propose like a collaboration with some of these companies? Because like Thai Power, for example, has a lot of sustainability targets. So with TSMC is part of the Restore Fund along with Apple. So they buy carbon removal credits at scale around the world. So they could be like a potential partner for an offtake agreement. So can we like propose specific companies as part of business model?
I think so. First of all, the economic environment in Taiwan is pretty centralized. Like you have a bunch of companies in each space. So if you're identifying a market for a new business, you're going to end up with 5 names no matter what. So I think it's fine to propose targeting partnership with specific companies because unlike India or the US, we don't have like hundreds of companies in every space. So that makes sense. But, let's also verify that with the consultant that we bring in and we have an additional chat, let's make sure that makes sense from an actual experience perspective. But we work with all these companies directly as well. So I think it's definitely in scope to propose having them as a client. All right. And let me jump to your last questions. The judging criteria, commercial feasibility, with or without subsidies, or should we model a carbon fee? So we took a look at this question. What we're thinking is that realistically, you'd probably be starting out with a heavier weighting of government subsidies and then moving towards revenue generated either from clients or a carbon fee. So what we're suggesting is maybe have a financial model that starts with a heavier government subsidy and then earns out over time as the market starts to move away from subsidies towards revenue or some sort of carbon recovery fee. Does that make sense?
Yeah.
Okay. And then you're asking what separates a good proposal from a winning one? Depth of financial modeling versus unique value proposition. We're not looking for super sophisticated financial modeling, even just like I just said, like a straight line projection on the transition of subsidy to carbon revenue is fine. We don't need detailed, state-of-the-art financial modeling. We're not really there yet. This isn't really a financial modeling competition so much as just a bridging the gap between science and the market. So don't go heavy on the financial modeling. I've been in part of competitions in the past where people went super crazy with all sorts of financial models. We really don't need that. It's more about your second point there. What is the unique value proposition to Taiwan? And so there we are looking for help us bridge that gap from our amazing, you could see we have amazing researchers and then we have the marketplace and we really need you guys to help create that bridge in between the two.
Got it. So just a question on this. I think it'll be important for us to like calculate. So we were thinking of, you have maybe 10 use cases for the biochar. Can we calculate the market size and the unit economics for each of these? Like how much revenue in total could we generate? And what would the profit margin be of selling in, like, let's say clothing? So I think that would be really helpful, but it would involve making a number of assumptions, right, around the cost of production, the cost of transport, etc. So is it appropriate for us to then make those assumptions based on like our best judgment, given like financial modeling is not meant to be very complex?
Right. I think so. I mean, I think that's how all these sorts of competitions work, is that you're working with a first draft, and then, you know, let's say the competition is your project is successful and we take it to the next stage, then we would get sharper and sharper information. But this is, you know, we're dealing with a couple of weeks of time here, so it's definitely going to be a first draft, best guess of what info you and I are, you know, I'm also happy to help point you to the right direction, but what info you're able to get from afar via the internet and our experts over, you know, a couple of weeks time. So I think that's totally fine to do it that way. Great. Any more? Do you guys have more questions on biomass while we have our three professors online?
I had one more question. So, do we have any data on the moisture content percentage of L2201 at harvest? Because, you know, when you pyrolyze the biomass, it needs to be dried. The biochar company I was working at, like we had to, you know, like actually keep it out in the sun and dry it. So grass is usually like quite wet, right? And that also adds weight when you transport it. So is there any data on that?
Maybe I answer this question.
Thank you, Rachel.
Around 80% is very high. So yeah, for pyrolysis, I suggest maybe make use of the juice, crush and take out the juice, and make use of the juice to produce the other purpose. So the water content become less, then you do the pyrolysis to save energy or time. Yeah. Like sugar cane, we eat the sugar cane juice. And this juice, I think, contains around 7% of sugar. How to make use? You can think of it.
Oh, wow. Okay. So similar to sugarcane in that way.
Yeah.
So 80% moisture content at harvest.
Yeah, around, yeah.
Oh, okay. That's huge. All right. All right. That's an interesting angle too.
Yeah, that's super interesting.
Yeah, very exciting.
Cool.
Very
I
great.
think one more question I had. The policy recommendation document, this might be outdated. It suggested using 50,000 hectares of fallow land. So is that land like, you know, what is the ownership of that land? Is it owned by like farmers? Would we, you know, like lease that land, manage the labor on the farm? Like who will harvest the grass? Like is there any sort of detail around that?
It's not a question I would know too well. I don't know if Rachel or Lin Lao Shi or Shi Lao Shi have a understanding of if we're growing more of this grass, who is growing it and who's doing the harvesting, who owns the land, how do we see this working in the future? Do we have an idea?
Yeah, I think it's a key point. Who to plant and harvest? Is it possible to have a certain agent to do this? But I think government would not like to take up this responsibility. So whether there's some corporation or something agent, they can help to manage the planting and harvesting and send for the biochar production or the other purpose. I think for the small farmer, maybe they can plant them. And it's good to, because we have very small scale of farm in Taiwan, it's good to have a corporation or something to handle large scale of maybe 100 hectares instead of 1 or 2 hectares. So they will cost down the production scale also.
So Rachel, do we view this going forward as maybe integrating with farmers' existing operations, that farmers might have an incentive to switch crops to Langweitao, or the fallow land?
Yeah.
Fallow meaning like unused land. Like how would that be? Would that be farmers who are using that?
For planting farmer, I think it's very easy, but for harvesting, they need the machine.
Oh,
It's better to have an integrate corporation or something to do the or rent the machine for the small farmer.
mm-hmm.
Maybe we need an agent between to handle this. Maybe a new business, yeah, for this
Okay.
purpose. Yeah.
Yeah. So guys, I don't think it's, go ahead.
May I add some information? As several years
Please.
ago, I calculated the price of the Napier grass and paddy rice. The per hectare the farmer can earn or can get the money from the Napier grass is just only half, maybe 30% to half relative to paddy rice. So if you want the farmer to transfer from paddy rice to cultivate a rice to Napier grass, they will reduce their income to half. So it is a very critical issue for a farmer. So if we want to add some interest to the farmer, maybe the carbon interest or carbon fee, or maybe some to energy or to clothes, it's much important. Maybe we have to double or triple of the Napier paddy rice Napier farmer. So they has only just in this case they have to for example investigate some machine to harvest. So it's too critical for a farmer if they transfer from paddy rice. So maybe you can draw a line, for example, how to double or triple of to the farmer. It is much important for them.
Okay, got it. So guys, it sounds like whether it's fallow land or just farmland that's already in use, the two key challenges are small scale farms are going to need to collaborate around harvesting, which I know in other industries that farmers do collaborate. Like I used to live in France in vineyard country, and they would all share the harvesting equipment. But Rachel suggests maybe we need some sort of intermediary to make that happen. And then the other angle is that Napier grass will need to be much more profitable for farmers to be willing to plant it. So it has to be, currently it's about half the revenue of rice, and it needs to be double or triple that for farmers to want to plant that. I'm just sort of repeating what Shi Lao Shi said. Go ahead.
Yeah, if there's any research or modeling done on this revenues, like that would be actually really helpful to see.
Yeah.
Okay, I will. Go ahead, Binaf.
Oh no, you go ahead.
No, I'm just coordinating.
Oh,
No,
okay.
maybe I add, because napier grass cost income is low, but whenever we think of the CO2 fixation as a carbon sink, maybe government can subsidize from this aspect, maybe more acceptable for the farmer to plant in this crop. You can think of it.
Right.
But
So if there,
the
go ahead.
the issue there is if the government is subsidizing for carbon sink, then you can't generate carbon credits from that because you'll be double counting. Because carbon credits are meant as a subsidy for creating carbon sink. So maybe like the government can purchase the credits, or a company like TSMC can purchase the credits at a higher price, or something like that would have to be put in place. Because in India, for example, the carbon projects we used to develop, one of the requirements of the registry is that it's not subsidized already by the government, because if it is, then your additionality is lower. Like you're not doing something additional.
Okay. Well, I think this gets into how Taiwan is going to approach carbon credits and carbon sequestration. Probably not a question for Rachel, I'm guessing, but we can pick that up maybe with our next call, if we can line up one of our consultants in the carbon credit space for you guys, and we'll get into how Taiwan is treating these this accounting. All right. Any other questions for our experts while we have them?
Nothing more from me.
One thing we looked into, and I don't know if the experts might have heard about this, is that some of the fallow land was because the government, or there were some policies that they had to control the amount of rice that they could plant for after the WTO. So then the fallow land is because they're not allowed to plant certain crops. And if we would know that, can we plant the Napier grass there?
Interesting. Maybe does Shi Lao Shi, do you know the answer to this? So the WTO impacted the amount of rice that Taiwan could grow.
Actually, no. We
Okay.
just only know our project. Yeah.
I'll try to find an answer for you guys on that one. WTO impact on rice production and land availability. Yeah, I'll see what our experts here know. That policy paper was written in collaboration with 200 experts, so a lot of this info came from many different people. All right, what else you got before we let our guys go? Any other questions from Binav or Garang?
All good.
Yeah, all good.
All right.
So much.
This is amazing question, guys. I'm really excited about your background, looking at it from India's experience, and now looking at it in Taiwan's experience. So we'll try to get you as much info as we can as you flesh this out. And we want to thank Professor Shi, Professor Lin, and Rachel Lao Shi for their help. Thank you guys for your patience and answering so many questions. Really appreciate it.
Yeah, thank you very much.
Thank you so much, Mark and professors, for your time and expertise.
No problem. I will stay on the line a little bit longer in case anybody managed to slog through the call and has any questions. But otherwise, if people want to drop, feel free to drop. But I will stay online for a few more minutes and see if there's any other general questions about the competition.
All good right. From my, I'll drop off. Thank you so much. This was super helpful.
Thanks for joining, Garang.
Bye.
Bye-bye.
Bye-bye.
Bye.
Bye. Bye, Hongpin. Thank you, Lin Lao Shi. Thank you so much.
Bye-bye.
Hi, Mark.
Yeah, go ahead, Alex.
I'd like to ask, do everyone in our group have to be Stanford students?
That's the idea. We were trying to make it a Stanford competition specifically. So I guess we could look at it case by case if there's a unique situation, but I think the overall hope was that it would be Stanford students. What is your situation? Do you have another student in another university who's interested, or?
Yeah.
Okay.
I,
Go ahead.
no. Yeah, basically that. I have a friend who doesn't go to Stanford and they're interested.
Okay. Let me run it by our team here. I'm slightly concerned about it not being fair to other teams who are just Stanford students, because then suddenly it becomes like a nationwide competition. Yeah. If you can shoot me your contact info or connect with me on LinkedIn, I'll get you update within the next day or so.
Thank you.
Yeah. And anybody else online have any other general questions about the competition?
I was curious about maybe like the opportunity to use some Chinese in the presentation and what you would think about that.
Good question. Comes up in my work every day. I would say if you want to make it bilingual, that's fine. I would definitely keep it, have a base of English and then add some Chinese as for clarification. That's what I often do with my presentation. So I would say feel free to add Chinese as a reference. But I would say also to keep it on a level field for everybody else. Like, let's use English as like the base language. Does that make sense as a way to operate?
Yeah. Do you find that there are specific aspects where having some Chinese just might be helpful for the judges so that they can like fully like engage with the presentation, like certain types of words or something like that?
Maybe. I mean, our judges will be fluent in English, so you don't have to stretch too hard to make it too Chinesey. But if you want to put Chinese for context, I think that's always helpful. Yeah, but I wouldn't overdose on making it fully bilingual, because we're really looking more for the business plan, like the bridge between science and the market, versus like how good one team's Chinese is versus the other. Because sometimes some teams will have maybe fluent Chinese speakers and some will have none. But we're really evaluating them more on the business concept versus their Chinese ability. So if you want to add Chinese, that'll be good, but don't spend all your time trying to translate it. Because sometimes you think, like this happens to me a lot, you start adding a little bit of Chinese and before you know it, you're spending all day trying to, round out all the missing pieces. So that would be my suggestion. Just use it as you think it's helpful, but don't feel like you have to do everything bilingual.
Sure, that makes sense. And then do you feel that maybe it would be useful to have like a starting slide that's like, maybe these are some specific challenges we identified in Taiwan, whether that's like soil erosion or fallow land that's being unused that the government's trying to find some use for, and then kind of framing it around these specific problems Taiwan has, so it's like customized to the country and the issue?
Absolutely. The more Taiwan focused, the better. Like, we're very much looking at this from a Taiwan angle first. And maybe these market solutions can be taken on the road in the future, but this is very much intended to be, what can we do to help Taiwan specifically? So yeah, definitely make it as targeted to Taiwan as you can.
Okay, thank you so much again. This was like incredibly helpful.
Okay.
Keep working on this exciting project.
No, please keep going. Please keep pinging me if you need help. I'm just gonna or you know what, I will get back to you on the dates for the announcement, because I don't want to jump screens too much. But any other questions to everybody out there, feel free to ping me anytime. And we're very excited about the momentum that we're building in this competition. Was there anybody else out there who had questions at this point? It's already been almost an hour and a half, so I appreciate everybody's patience.
Thank you.
All right, thank you everybody, and we will have this session next week again, so feel free to join again next week. Okay, thank you everyone. I'll sign off for now. Bye.
Bye.
Bye-bye.
Bye.
Thank you, Miao Xing.
Thank you.
Thank you.